Hey everyone, another day, another DSA problem. So today we're going to be looking at 1914, cyclically rotating a grid. So this was actually yesterday's daily problem. I didn't get time to make a video, so yeah, here it is now. All right, so the question states that we're given an mn to n integer matrix, a grid, where m and n are both even integers, and we're given an integer k. So basically k represents the number of times we want to rotate it anti-clockwise. So yeah, this problem basically tells us that we have a bunch of layers. So here, this is the outer layer, and then this is the twos are the inner layer. So we're gonna have a lot of layers, each of like a thickness of 1, and we want to rotate each layer cyclically by k rotations. All right, I think it'll be better if we take an example over here to kind of understand this. So what they're telling us is that we have a certain number of layers, right? So here with the first layer would basically be this, all these values to kind of the outer layer right here, and then we'd go to the inner layer. So if we look at this, grid right here, we have one layer, and then on the inside we have another layer. So yeah, this is 2 layers. So let's take an example and see what exactly they're trying to ask us to do. So this is an mn to n grid over here, and let's take our value of k to be something like 3. So we want 3 rotations, right? So basically that would mean this one over here would go 1 hop, 2 hop, 3 hop, and this would actually become 1. So let's check that out. If we're going to do that, what's going to happen to this grid over here, right? So as I said, 1 would go from this position to 1, 2, 3, this position. So if I start filling those values in that same way in our cyclic first layer or our first outer ring, my value of 1 would be going here. And then I see my next value is 2, so 2 would shift here, 3 would shift here. Then we have a 4, a 21, 22, 24, 26, 28, 27. So you see I'm basically just taking these values. Then we have a 9, 10, 11, 12, and this 13 would come here. And we have a 14. So yeah, if we shift it by 3 positions down, anti-clockwise, this is what's going to happen to the layer. And again, if we go to our next layer over here, which is actually this one, so we would end up having phi goes here, here, and then here, right? So our 15, sorry, that's 15. Then we have a 16, 17. I did something wrong. It's 23. No, it's 25, 18, then 19, and then a 20. So yeah, that's the shift of the inner ring. So yeah, this is basically what the problem is asking us to do. So it would help to make a few observations before we actually try to see how to figure it out, the solution out. So let's look at the observations that we have over here. So we are told that the grid is made up of multiple layers, right? So we have these kind of rings, right? And each one of them has a thickness of 1, right? And so let's try to figure out, if we want to solve this layer by layer, we need to know how many layers we actually have, right? So let's look at this and try to see. So we know that in this we actually had 2 layers. Now let's try to look for a formula where we can tell that we had 2 layers, right? So I can see that this is 4, and I can see that every layer has like a thickness of 1, right? So if a thickness of 1 is coming from its left side and 1 from its right side, then we know that if I have a maximum of like this width here, then I could probably have 2 layers because that would be the thickness. And now we know that m and n don't have the same value, so our rows and columns could vary. But just look at this. It's going to depend on the smaller one amongst those, right? So right here we have m for the rows. We have m is equal to what? It's 6, and we have n is equal to 4, and we have 2 layers. So let's say by the formula, if we have to take that would be, so it would be minimum of either the rows or the columns, and then we divide that by 2 because a layer needs like one left side and one right side, one wall to make that. So if we had actually taken like minimum, if we had actually not taken the minimum and we took like something like 3 here, so it was 6 divided by 2, we don't have 3 layers, right? Because this is 1 layer and this is 1 layer. So it's always going to be defined by the smaller one of those sides. So yeah, that's our formula over here. It's going to be important later, so we want to kind of keep that handy. All right, so let's kind of go through the approach and we'll see how we can figure this out, right? So one thing we can tell now is we're going to go layer by layer. So let's just focus on one single layer. All right. And if I look at the layer, I mean, right now it's in 2D and it looks pretty complicated. But what if I took all of these values, I kind of just added them to a list, and then I convert that into a one-dimensional array. And then I just rotate it however, like whatever is asked for, right? That would make things very simple. So let's see. That's our first intuition, to convert this into something that's much more simple to process. So let's see how we're going to convert this into an array, right? Now, to compose this layer or this whole ring, we have 4 walls, right? So we have a left wall, we have a bottom wall, we have a right wall, and we have a top wall. So the left wall is basically going from top to bottom, right? So we are going from top to bottom here, right? And then the bottom wall is just going from left to right because we're going anti-clockwise, right? So this is going from left to right. And then the right wall is going from bottom to top. So that's bottom to top. And then in our anti-clockwise direction, so we go like this. So the top row would be going from right to left, right? So these are the movement patterns that we take to go kind of anti-clockwise. So we want to traverse this for the first layer, for each layer actually, and we want to take those values, add them to an array so we can do the rest of our processing on that, right? So we actually need to figure out a way in how we're going to convert these, right? So let's look at the coordinates over here, right? We have, okay, so our layer number right now is we're at layer 0. Let's try to use that. And let's see. So if I look at the coordinate for my left wall over here, I see that the column is remaining the same. And right now I see the column value is actually just whatever layer I'm at, right? So we are going to put the constant value over here. So whatever remains constant for this, that will be its fixed coordinate, right? So layer is where our left wall is, right? And then we can iterate by kind of just running through the number of rows and using the same layer for our column. Okay, so now let's try to find a fixed value for this one. Okay, so we see that this is at the 3rd row, right? So we know that it's always going to be to the bottom, right? And our total number of rows is actually rows is equal to 4. So I can write this as rows minus 1. But it's rows minus 1 because I'm on like the first layer, which is 0. But if I was here on our second layer, then it wouldn't have been rows minus 1. It would have been rows minus 1 and actually the layer that we had taken. So subtracting that layer as well. So it's rows and then we're going to subtract this layer because we're not using it, right? So to write that, the formula would be bottom would be rows minus layer minus 1 because we're going that much to the top, right? And then we're going to look at the right one, right? Okay, so let's see what's constant here. We obviously see that there is a fixed column. And what is this column, right? So this column, in the same way that we were talking about bottom, right, would also be the same. But it would be columns minus layer minus 1. So in this case, columns is 4 minus the number layers minus 1. So we get 3. So we're at an index 3 over here, right? Okay, and for top, it's pretty easy because, again, it's just at 0. So it's, all right. It's obviously just going to be a layer again. All right, so we have these coordinates, and we're going to use this in our transformation. Then we're just going to go through the variable other coordinate value, and we're going to get those, and we're going to add it to a list. All right, so let's just check that out here. Let's say initially we go from left wall to bottom wall to right wall to the top wall. Let's do exactly that, and we'll start adding this to a layers array, right? So what am I going to do? I have 1, then I have 2, then I have 3, and I have 4. And this is my left wall, right? And then I've already taken 4. So I don't want to start from the exact value of where my left was. I want to start from left plus 1 because I don't want to repeat the value, right? So I want to start from this index wherever 5 is, right? So then I'll add 5, I'll add 6, I'll add 7. Okay, so this is traversing my bottom. And when I go to the right one, I see that I've already taken 7. I don't want to take 7 again, right? So whatever value that I have here for my bottom coordinate, I want to take it from one value less than that, right? So we'll start from bottom minus 1, and then we'll go to the top. All right, so let's take those values. We take 8, 9, and 10, right? So now I'm at this position. I don't want to repeat 10 again, so I want to start from the value before that, actually, because we're going in this direction, right? So if this was right, then this position over here would have been, this would have been, all right, I think I'm just gonna, so this would have been right minus 1, right? It would be right minus 1, and since we've already taken our left part, so we want to go to left plus 1 over here. Okay, so this is how we're going to traverse it, and after 10 I get values 11 and 12. So this becomes my single one-dimensional representation of my entire ring. Now we're going to see how we're going to rotate this and put it back. Okay, let's look at that. Let me rewrite the layer over here. I think that was a little messy earlier. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wait, that was it. Okay, and we're going to take a k value of 3. Okay, so if I want to rotate it anti-clockwise by 3, I know that 1 would go from here, 1, 2, to this position, right? So I know that everything is right rotating, all right? So 1 would go from this position to 1, 2, 3, this position over here, right? So what I know is when I do a right rotation, all of these values will be shifting to the right. And that also means that if I shift by 3 positions to the right, then those last k positions would have shifted to off the grid, right? So if they go to a position before that, that means they have to come to the front. So basically, if I shifted everything to the right by 3 positions, then these 3 would have just gone off the chart, right? So that means I actually have to bring that to the front. And if I do that, then I can write that as, so if we look at this, these are the last k values, right? So I can take the last k values, put them to the front, and then take all the remaining values up to k and put them to the right. So we know that in Python, this last index is represented as -1, this is -2, -3. So this is basically going to be, this rotate value is basically going to be like minus k. So then it's going to go over here and we'll bring that over here. So 10, 11, 12. And then we have our 1, 2, 3, 4, 5, 6, 7, 8, 9. Everything gets shifted, right? So all of these things get shifted to the right and those get shifted to the left, right? So one more thing is, as you guys would already know, so when we're doing a rotation of k times, so the formula to kind of summarize, to kind of condense this value or something, I would say is k mod the length of the layer itself. Because let's say 1 started here and we have a total of 12 numbers right here, right? So if 1 actually shifted 12 times, 1 would just come back to the position it started in. So it doesn't make sense to kind of repeat this to k times because k is just it actually becomes like mod length of whatever array we have. It comes back to the same position. So we're going to take that as a separate value of rotate. We don't want to update k itself, because k has to remain what it is, because for the next layer we don't want to change that value of how many rotations happen. Okay, so we're going to have a separate value rotate, which is going to be k mod length of the layers array. Okay, so then, as I mentioned over here, our new layers array will be formed by taking our earlier layers array, but we are gonna start from this minus rotate position, rotate, not k. So our minus rotate position to everything after, and then we're gonna add that with layer of array for everything that started and up to k, right? So everything up to our minus kth position. So yeah, that's how we're going to rotate the array. And basically, after rotating that, we have what we need. We have our anti-clockwise rotated values, right? So we just go back. We follow the same method that whatever we followed here, and the path left, bottom, right, top, and we just go and fill it with our new values, right? Seems very simple. So let's just do that here. But yeah, here, but it starts from 10, right? So I have a 10, 11, 12, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So if we look at that, 1 had started here, it went 1, 2, and it shifted here. And the same thing happened for all of those. Okay, so basically we're just doing it layer by layer, and obviously our values here will adjust accordingly to the layer that we're in, because we're in a certain range, and as we have seen here, we have taken layer in these considerations. So yeah, they just modify on their own because of this formula, and we just do that for each layer. Okay, so let's talk about the time complexity for this. So one thing we do is we are going through each cell once when we're extracting it, and we're going through it once again when we are adding those values back, right? So that's actually 2 times m into n, but we can drop constant, so it's m into n. And then size, okay, not size, sorry, space. So what's happening? Space is actually this array that we have considered over here, right? Because every time when we are creating this layers array and then we're kind of modifying it, we are using a layers array. So what is a layers array? So it's basically like whatever circumference or whatever this value is contributing, right? And that would be this plus this. So it's like it's 2 times of like the number of columns that we have. So 2 times columns plus 2 times rows, right? So that's how we're going to get it, but we can drop the constants and we can represent columns as m and rows as m and this as n or something like that. So again, yeah, it's just going to be 2 times m plus n, which is basically O of m plus n. Okay, I hope you guys understood the solution. So we're just going to go to the code, which is exactly the same as what I just explained, but I think it'll be better to understand it here. All right, so we had talked about this. Our first consideration to make would be layers would be the minimum of rows and columns divided by 2, because each ring has a thickness of 1 and comes from both sides, so that's 2 for 1. Okay, and yeah, we're going layer by layer with the number of layers that we have, and basically it's going to be the same thing that's done per layer, but just this value of layer will help us kind of do those modifications for the corresponding layer. Okay, so yeah, we've come here, like I mentioned in the diagram, so left, let's see here. So yeah, right, we had left was equal to layer, bottom was rows minus layer minus 1, right was columns minus layer minus 1, and then top was layer again. So here we're just iterating, right? So as I had mentioned, the left component had a fixed column. So our column value for the left component was layer itself. And the varying value was the rows, right? So we're just taking that, everything from the left, and we are adding it to our layer array. And then for the bottom one, like I mentioned, we don't want to start from this position here, but we want to start from this position, which is actually going to be, what's it going to be? So yeah, it doesn't start from left, it starts from left plus 1. And I'm writing right plus 1 because right is this coordinate. And as we know that Python, if you want to iterate to that value, you have to add a 1 over here, okay? And then for the right column, we're starting from this position. And that position is basically right column, like right value. Okay, sorry, I'm looking at this one, that's wrong. Yeah, so this is, for this right one over here, it's basically whatever bottom value is there minus 1. So bottom minus 1 to top minus 1. So yeah, we're doing top minus 1 because we're going in negative increments. And if we have to go to till top minus 1 by subtracting, then meaning we're going till top. Okay, there's some Python stuff. Yeah, so we've taken this value, then we want to take this value, right? So this starts from, what is this? It's right minus 1, yeah? Okay, it's right minus 1, and we go up to left. Okay, so it's left. It's actually, if we go up to left, then you know in Python that we stop, we don't include that value. So it goes to left plus 1 because we're subtracting. Yeah, okay, so anyway, our rotate, as I had mentioned, we want to keep a separate variable. We don't want to modify k within these loops. So that's going to be k mod the length of whatever layer array, and the length of layer array is going to change each ring. And then our step 3 would just be this, the exact same thing which I had shown in this diagram, right? Okay, so yeah, this formula over here. And then, yeah, so once we get all of those values are stored in our layer array, which has now been rotated. So we want to follow the exact same path again. We want to go left, bottom, right, and top, because that was our anti-clockwise trajectory that we followed. And I just want to go and fill it with whatever values are stored in my layer array. So I'll just have an index, and I'll go incrementing that each time I complete a layer, and I'll just go adding those values. Yeah, that's basically it. And you just return the grid. And yeah, so that's our optimal solution here. Just write, so our time complexity was actually O of m into n, and our space complexity was O of m plus n. So yeah, that is the solution. And yeah, it looks like a complicated question, but once you understand this logic, I think you can't really forget it later on. But yeah, so that's how it's solved. And happy coding, everyone.